Bonjour tout le monde, bienvenue au Bracket Show. Donc, Bruno Barrette en direct de la première journée de Confoo et je suis avec Jeremy Cook. Hi, Jeremy.
Hi, how are you?
Pretty good. Yourself?
Good, thank you.
All right. Before we dive into the subject of this interview, maybe starting by telling us a bit about yourself, what you do.
Sure. Yeah. So I usually describe myself these days as a Canadian with an English accent or an Englishman with a Canadian passport. You can pick which one you prefer. And I'm a senior principal software developer at Oracle, and I work out of the Waterloo, Ontario office. Normally, I should say, I'm currently broadcasting from a location in Guelph, Ontario.
Okay.
And yeah, so I mean, a lot of my time is spent working with teams, helping identify the practices, helping individual developers to have skills that they need to do what we need them to do, working a lot on software architecture as well.
All right. So if we move on about today's topic, I read in your bio that you're a fan of clean and maintainable code, which
Yep.
is something that rings a bell for me. So software architecture, obviously. My first question, what is your definition of a good software architecture?
That's a great question. A good software architecture would be one that the team has considered and identified the things that must be supported to make the product successful. I think, you know, I used to be a professional musician, and people talk about playing music as being, the music is in between the notes, not the notes. And I sometimes think with software architecture, the architecture is between the requirements, not the actual requirements, right? So an example would be, let's say you're designing a system that does, let's say, concert bookings, and you publish concerts, and there's a flood of traffic to your site. The requirements might say, you know, we publish events and people can book tickets. An architect has to read between the lines and say, well, I need to support elasticity. But if I can't scale suddenly to support all of these concurrent users, the system is unlikely to be successful. So I think it's about identifying those things, designing something to support as many of them as you can, and when you're making trade-offs, being very explicit about what you're trading off and why.
Okay. What do you think are the traps when you're designing your application's architecture that can lead on the other end of the spectrum to a bad architecture?
I mean, I think the answer for any question in software architecture is it depends, right? There's one of the problems we have in software with architecture is that there is no single definition of what architecture is or what architecture means to everyone. And so in terms of a bad architecture, it depends. I mean, you know, it's possible to over-design something, make something overly complicated. It's possible to miss something that then becomes crucial and makes the system fail. You know, both of those extremes are equally as bad. You know, it's how do you arrive at the happy middle ground where you're able to justify why you're taking certain decisions and to explain to people why these things are important. So fundamentally, I can only answer that question with a non-answer, I feel.
Mm-hmm. So, yeah, because sometimes a good architecture for one purpose will be a bad one for another one.
Exactly.
So
exactly,
it's never an easy answer, right?
Yeah, exactly.
This brings us. Oh well, go ahead. No, go ahead.
I was going to say, I mean, an interesting exercise I've been doing with some teams that I work with recently. I don't know if you've ever come across this idea of architectural katas. Neil Ford talks about them a lot, and he has some examples on his website. But the idea comes out of this idea of how do you get good at anything? Well, you practice. You know, artists become good at art by practicing, right? So how can you expect people to be good at software architecture if they only get to design a system once or twice or 5 times in their careers? And so Neil has published this collection of architecture katas, and they're all kinds of ones. Like one of them would be to design a hotel booking system. And usually in the requirements, it's phrased along the lines of functional requirements, but there's all kinds of things thrown in there. Like they might suddenly say, oh, by the way, the customer has no budget, you know, and then of course that influences how you design the system. So, you know, if anyone's interested in that, I'd highly recommend, you know, pulling together some of your team members and sitting down for an hour or two and trying one of these architectural katas.
All right, that's a good idea. Do you think, speaking of working as a team for this, how can you start doing architecture without having a mentor or a more experienced architect with you that can bring you up to speed? There's no, like we said, there's no definite way of doing it. So how do you start in this?
It's a great question. I mean, I would always look to lead developers or more senior developers in your organization to be helping you with that. But I also fundamentally think that the role of the architect is an enabler, right? That anybody can be an architect, anybody can, and I do think the whole team is responsible for architecture, not just one person. I very much dislike this idea of the architect as designing something and then saying to the team, here, go and build this. In terms of, if your team really doesn't have that person who can help you and enable you, one structure that I've used a lot, I think very successfully with teams, is in the early stages is to categorize things, to try and identify different types of things that are important to your software, to your system. And the kind of categories I've used come from this book called Design It. And they suggest 4 categories. I had a 5th. I think, let me see if I've got this right. But the first one of which is constraints. Like, can you identify any large constraints on you which are going to influence how you choose the architecture? So for example, if you're working, I work in a Java shop. If I was to design a system that requires to build in root, to get that accepted is likely to be extremely high. So to add that to our stack is going to be very difficult. The second one of which is identify architecturally significant requirements. And what this says is that not every single functional requirement is going to have a bearing on the architecture. So if the product manager says to you, make the background of every page purple, it's unlikely, on a web application, of course, it's unlikely to change how you would architect the system. But there are another whole category of requirements that will have a very, very significant bearing on the architecture, like the example we used earlier, the ability to, the elasticity to scale to sudden bursts of traffic. And if you miss those, you're more than likely to fail. The third one is identify quality attributes, or these are also called architectural drivers or architectural characteristics. They're interchangeable terms for the same thing. But if you can identify that you need scalability, that you need high performance, that you need accessibility, whatever it is, and I think for each of those words as well, define what it is for your project, because performance can mean many different things. And then it's kind of a catch-all category of anything else, right? Technology preferences, team skills, you name it, anything else that you can think of has a bearing on the architect. And for that one, for the 5th one that I add is risks. Can you identify significant risks to the project that might have a bearing on the architecture? So I find that if you think of those 5 categories to start with, even if you have as an architect role on your team, if you begin to think of those things, what you kind of do is you establish gateposts. These are the things that we must support for this product to be successful. The step after that is to really then design something that gives you whatever it is that you've identified. If you're saying that high performance is important to you, show how what you're proposing is going to meet that need. Now, what usually happens is that it's impossible to design a system that gives us everything we might wish for. And that's absolutely fine, because, it's about identifying the trade-offs and being very clear and saying to your product manager, I can give you high performance, but it means we're going to lose some aspects of security or whatever it is, right? Is that okay? So that's the kind of process I recommend to people, and I've seen a lot of success with, I think, in helping teams to identify those things.
And how can budget impact all this? Because of course we'd all love to have unlimited budget and we can do everything to make the perfect architecture. A lot of times it's not the case, and more times than others the budget is limited. But you have at one point to make the decision of doing something that you would consider bad, but that you don't have the choice. How do you weight the balance between the two?
Yeah, that's another great question. I mean, budget for me would fall under the category of constraints, typically, right? And let's face it, there's always a budgetary constraint. No matter how big your budget, somewhere it's going to run out. So I think, again, it's about understanding the trade-offs. You know, if you cannot meet all the other functional requirements and architecturally significant requirements and whatever it is you've identified within the budget you're given, again, exposing that as quickly as possible enables the conversation to happen about what are we going to trade off? You know, how can we deliver a fraction of what it is that we want, or some smaller piece of what it is that we want, but still put ourselves in a position where we can expand in the future as and when time and budget allows. I think, you know, the real danger comes when a team says, you know, yes, we can do that, no problem. You know, 6 months and yeah, you know, we can do it for $5,000, no problem. And of course, you get, you know, 18 months into the project and you're way over budget, and you know, so avoiding that kind of situation is to everyone's advantage. I mean, I also think that this really comes into the idea of evolutionary architecture as well. But something that I became aware of a couple of years ago, there was a really great book written in part by Neil Ford and Rebecca Parsons and Patrick Quah called Building Evolutionary Architectures. And the idea that they posit is that traditionally, even the term architecture makes you think of something foundational, something that can't be changed, something you have to get right early on. And they suggest that we can turn that idea on its head. We can design software architectures that are evolvable, that can change as and when required. And they suggest that the way to do that is by testing your architecture. You know, they call this fitness functions. And so, you know, once you've identified the important things your architecture must support, build some sort of test, whether it's continuous monitoring or something you do in your continuous integration pipeline, some sort of test that verifies the system actually exhibits that quality. And once you have that test in place, the underlying architecture can change as much as you like because you're verifying that the behavior is still there.
Okay.
And again, this is very similar to unit testing, right? The unit test enables you to change the code. The implementation can change as long as the external behavior, the observable behavior doesn't change. In this sense, the architecture can change as long as the behavior it gives isn't changed, it doesn't alter, it doesn't get worse.
Right. I think that brings us to the second thing I wanted to talk about with you. It's ArchUnit. I'm not sure about the pronunciation. ArchUnit. Yeah, well, for people that, like me, didn't know this until the moment I read your subject, can you give us a brief explanation on what it is?
So ArchUnit is a library that runs as part of your unit test suite. So ArchUnit tests just a standard JUnit test, and this is a Java library, but it lets you test your Java architecture. So the parts of your architecture that are expressed in code, like the structure of the application, naming conventions, all of these things, what should depend on what, you can write tests for in a very, very expressive style and very quickly verify that the code actually has the things that you think it has. That's kind of the nutshell definition of it.
Okay. And I also saw in the syntax that it's a Fluent style, so it's easy to read and makes sense.
Yeah.
I'm a big fan of test-driven development. So do you think those tests could be even before starting your different layers? Can you turn this architecture testing into a test-driven development to really define your architecture?
Yeah, and that's an interesting one because I think you can. I think the thing you want to avoid is trying to define everything up front. And then the risk is you end up with an annoyance to developers because obviously, you know, no plan survives its first contact with the enemy. I think one of my managers is fond of saying that. But, you know, as you start to write the code, your understanding of what it is you have to deliver changes. So the risk obviously is if you have a big suite of architecture tests up front, as people are coding and they make small changes and the understanding evolves, the tests change so frequently that it becomes an annoyance. So I think there's definitely a sweet spot where you've made major decisions. You've chosen Onion architecture, for example. You can write tests that verify, you know, you've identified what packages or how the code is going to exhibit the characteristics of that architecture. You can write tests that verify that. And as you go along in development, add more and more things that are specific, that are valuable to you. If you choose a naming convention, or you choose a particular package structure, or you don't want certain classes to throw certain types of exceptions for whatever reasons, all of these things can be tested and verified. And what you end up with is a suite of tests that guarantee your code has the qualities that you think it should have. And in the future, it stops unintentional change from creeping in, because we all know that architecture tends to decay over time, that this architecture erosion is, you end up losing the very things that you tried to design into the system to start with. And a suite of tests like this will really ensure for you that that doesn't happen unintentionally.
Okay. Could you even go as far as integrating domain-driven concepts in this to be able to actually talk to your client with fluent style, again, with sentences that tells the client what the software will do? Because if this test sentence, if we could say, doesn't make sense for him, it's probably a smell.
That's interesting. I haven't thought of it in that way. I mean, I think if by clients we're talking about, the people we're delivering the software to, I'm not sure that these tests communicate a lot to them in the same way that like business-driven development might do. Because we're really saying, so the ArchUnit Fluent Syntax is that architecture, so in ArchUnit, you identify some code you want to test, and then you write one or more rules, and you verify the rules against those classes you've imported. Yeah. The rule syntax really is fluent. It reads just like English, and it's with a builder syntax. So you might write a architecture rule that says classes that reside in a package service should only have dependent classes that reside in service or controller. That will be your rule. And there's a method for classes .that reside in a package, and then you provide the package name as an argument .should and so you build it like this. So when you read the code, it does just read like English. And when the test fails, the failure method, the name of the rule, is actually constructed out of the names of the methods that you built the rule out of. So in terms of value for clients, I do think that this speaks more to the internal, what the developers have chosen about the structure of the code within the domain, not so much what the client would expect to see. But it's hugely valuable to the development team itself.
It's not like business development tests where you can actually have jargon language to help the client tell you what they need. We're on a more technical level.
I think so. I mean, it's very similar in the sense that the code, the test does read like English, but the audience, I think, is different in this case.
Okay. And maybe last question I have about this. Where would you put those kind of tests in the famous testing pyramid, where you have a lot of unit tests at the bottom, end-to-end tests obviously on top that you don't do a lot? Where would you fit those?
An interesting question, because as far as I understand it, at least, is really talking about testing behavior. And with ArchUnit tests, you're actually talking about testing the structure of your code. It's really almost a form of static analysis, but done as part of your unit test suite. So one argument you could say that in terms of the test pyramid, unit test level, they're fast executing, and that's actually a huge advantage of ArchUnit, because oftentimes with architecture testing systems, it runs separately to your main build. It's over here somewhere. If it fails, someone has to remember to check it. Because ArchUnit tests are actually part of your unit test suite, architecture violations become test failures, which become build failures. And you've shifted the problem as far left as possible, because it makes it impossible for the team to ignore that and not be aware of it. Like they have to make a decision about what to do about this, even if the decision is let's just delete the test. Right? They've made that decision. So I think that's part of the value of it. But it doesn't really fit in within the classical idea of the testing pyramid.
Right. But do you think, like, if someone would have a really huge suite of architecture tests like this, could it mean a smell? Are you maybe over-architecturing your application if you have a gazillion tests that's verifying every dependency or...
I would think so, in the same way that anything taken to an extreme can be a bad practice. It's to my mind, it's about identifying the important decisions you've made in your code. We pick these decisions to give us maintainable code, understandable code, testable code, evolvable code, right? If you can identify the decisions you've made about the layers of your architecture, how things depend on each other, naming conventions, any convention that you're expressing in the code, you can potentially test it. Now, again, the trick is between testing enough that you can be sure that that's not going to decay silently without you being aware of it, and testing it so tightly that you're effectively putting people into a straitjacket. Like with ArchUnit, you could potentially test that every single method you write in every single class matches some naming convention. Would that be valuable? I don't know.
You would probably restrain the developers.
Yeah, exactly. Yeah.
Okay.
Again, it's up to the individual to decide what is the right amount for their needs at any given time.
Finding the sweet spot.
Definitely, as always. Yeah.
All right. Yeah. So that concludes the questions I had. That was really interesting. Coming from a more .NET ecosystem, I wasn't aware of this. I actually saw that there's a .NET port of ArchUnit, so I'll definitely have to check it out.
Yeah. I mean, if you're interested, maybe you've already done this, but the ArchUnit website has got a very compelling, quick start, right? Complete with a GIF video showing you how to write these tests, and you put it in an IDE and you start typing classes.that, and the completion says gives you a huge list of things that you can check. So it's exceptionally easy to get started. And I imagine from the little that I've seen, that the .NET port is very similar in a sense.
Probably similar, and the Fluent pattern is available in most testing libraries. So yeah.
Yeah.
All right. Yeah. Well, again, thanks a lot for your time. That was really interesting.
Great.
Thank you.
Thank you.